Hey everyone, and welcome back. Today we're diving into one of the most important practicals for your GCSE chemistry exam, titration. We're tackling required practical number 2, and trust me, getting the hang of this one is a huge deal for hitting those top grades. So let's get right into it.
All right, so just picture this for a second. You've got a solution, maybe an acid, but you've got no idea how strong it is. How on earth do you figure out its exact concentration? I mean, you can't just look at it, so what do? Well, that's the big question, right? And it's exactly what titration helps us figure out, with some pretty amazing precision.
So here's the game plan. We're going to cover what titration actually is, the kit you'll be using, the step-by-step method, and how to get your results down on paper. Then, for you higher-tier folks, we'll crunch the numbers, and finally, wrap it all up with the key things you've got to remember for the exam.
All right, let's dive right in. First things first, what on earth is a titration?
Okay, so at its core, a titration is basically a neutralization reaction. You've got an acid and an alkali, and you're making them react. But here's the really clever bit. You know the exact concentration of one of them. Let's call that our known solution. By measuring exactly how much of it is needed to completely neutralize your unknown solution, you can work backwards and figure out its concentration. It's kind of like being a chemical detective.
Now, to pull this off and get a result that's actually accurate, you can't just be sloshing things around in any old beaker. Nope, you need some very specific, super precise gear. So let's take a look at your toolkit. Okay, so every single piece of equipment you see here has a super important job. The pipette, for instance, isn't like a measuring cylinder. It's designed to give you one super accurate volume, say 25 cubic centimeters, every single time. Then you've got the burette. This thing is amazing. It lets you add the acid literally drop by drop and measure the volume to 2 decimal places. You see why that's so crucial for accuracy, right? The conical flask? Its shape is just perfect for swirling everything together without it splashing out. And that white tile underneath? It just makes the color change at the end so much easier to spot. No guesswork.
All right, so you've got the kit, you know the theory. Now for the fun part, let's actually walk through the method. If you follow these steps, you really can't go far wrong. So let's talk technique, because that's what this is all about. When you're filling the burette, you've got to make sure that little bit of space below the tap is full of acid, not an air bubble. If there's air, your first measurement's going to be off. The real skill here is controlling that tap. As you get close to the end, you slow right down, adding the acid drop by drop, swirling the whole time. You're looking for that single drop that causes a sharp, permanent color change. That's your endpoint. And here's the big one. You have to repeat it. You can't just do it once. You're looking for at least 2 results that are basically identical. We call them concordant results, so you can be confident your answer is reliable.
Okay, so you've done the tricky part in the lab. Now you need to show your results in a way that makes sense. A nice, clear results table is absolutely essential in the exam.
Take a look at this table. First thing to notice, every reading from the burette is written to 2 decimal places. Always. Even if it's a 0, you write 0.00. The titer is just the volume you added, so it's the final reading minus the initial reading. And see how the initial reading isn't always 0? That's totally fine. You don't need to refill it to the top every time, as long as you record where you started from. This is exactly how you want to lay out your data. It's clear, it's professional, and it makes the next steps way easier.
All right, let's get these 2 terms straight in our heads, because they're super important. Your first attempt is what we call the rough titer. For this one, you can be a bit quicker, just to get a general idea, a ballpark figure of where the end point is. It saves you a ton of time. Then, for your next attempts, your accurate titrations, you use that rough value as a guide. You can go fast until you're close, and then you slow right down. What you're aiming for are concordant results. That means you need 2 or more titers that are really, really close, within 0.10 cubic centimeters of each other. In our table, you can see we got 24.50 twice. Those are our concordant results. We'll use them to work out the average and just completely ignore that first rough one.
Okay, pencils ready. Higher tier students, this next bit is for you. We're going to take those lovely concordant results and use them to do the big calculation. Don't worry, it's just a 3-step process.
Step 1. You always start with a solution you know everything about. You know its concentration that was given to you, and you know the exact volume you used from the pipette. So you just plug those into the formula. Moles equals concentration times volume. But wait, here's the classic exam trap. Your volume is in cubic centimeters, but the formula needs it in cubic decimeters. So you've got to remember to divide your volume by 1,000. Do not forget that.
Okay, step 2. This is the bridge that connects what you know to what you don't know, and that bridge is the balanced symbol equation. You have to look at the big numbers in front of the acid and the alkali. In this example, with HCl and NaOH, there are no big numbers, which means it's a simple 1-to-1 ratio. This is amazing news. It means that at the endpoint, the number of moles of acid you added is exactly equal to the number of moles of alkali you started with.
And here we are at the final step. All you do is rearrange that first formula to find the concentration of your unknown solution. So concentration equals moles divided by volume. You know the moles now, thanks to the ratio in step 2, and you know the volume, that's your mean titer that you calculated from your concordant results. And just one last time, what do you have to remember to do with that volume? Yep, divide it by 1,000. And boom, you've done it. You've found the concentration of the unknown solution.
Phew, we have covered a lot of ground there. So let's just pause and boil it all down. What are the absolute must-know, can't-forget essentials for your exam? Look, if you only have a few minutes for revision, this is the slide to screenshot in your brain. First, know the purpose. You're finding a concentration. Second, know the key terms: titration, burette, pipette, endpoint. Third, know how to get an accurate result. You repeat until you get concordant results. Fourth, for higher tier, it's that 3-step calculation: moles, then ratio, then concentration. And finally, safety. Always use a pipette filler. You know, this really gets to the heart of it. Every single step we've talked about, every weird-looking piece of glass, it's all about one thing: precision. And the key to getting a grade isn't just knowing the steps, it's understanding why that precision is so important. Why a burette and not a measuring cylinder? Why concordant results? That's where the top marks are.
All right, I want to leave you with a final thought to chew on. This whole titration thing, it's not just some random school experiment. It's a seriously powerful tool. So how could you use it? Imagine you bought a substance that was advertised as 100% pure. How could you use a titration to check if you've been ripped off? Think about how you could apply this skill. It's more useful than you think. Okay, that's it for me. Good luck with the revision.